the history of PVC, the differences in the formulations of PVC, the different types of ways that PVC is installed, and we'll look at some of the different types of reinforcements for PVC. So a look to start off with two red cars. They will both get you from point A to point B, but other than that, there are big differences in the performance characteristics of the two red cars. So just because they'll get you from point A to point B doesn't mean they're produced exactly the same and have the same performance characteristics, and that's really the same thing with most products that are produced. There's big differences in the way you can produce them, formulate them, etc. And when we talk about PVC, there are differences in the formulations of PVCs, but in general, PVC is considered a very high-performance single-ply roofing product because it's very chemically resistant and it is environmentally responsible. Just a quick overhead view of a bright white PVC roof. And in that membrane construction, you will have a top layer with most of your weathering package in that compounded top ply. You'll have a reinforced scrim, and then you'll have a bottom ply. And the scrim in between is typically polyester, and then there is also fiberglass scrim that is used strictly for fully adhered applications. Typical ways that we would install PVC roofing are mechanically attached applications. In this slide, you have a 22 gauge metal deck, multiple layers of insulation, and a mechanically attached membrane. And then you can also have a vapor barrier where needed and appropriate. You have insulation systems. And PVC is also used in fleece back systems, which we'll talk about a little later in the presentation. All these systems will use heat welded seams. They are a thermoplastic product, and at the conclusion of heating the seams, you'll let it cool approximately 30 minutes, and then you'll probe the seams. Little history, PVC, the two main ingredients are natural gas and salt water, so it is not a petroleum-based product. And how we get to PVC from those main ingredients are you have natural gas, which you'll crack to extract ethylene, and then salt water will go through an electrolysis process and extract chloride. Combining those two ingredients, you'll come up with a liquid vinyl chloride monomer, which will be exposed to a UV light, and that will turn that into a white powder PVC resin. Of course, it takes a little bit longer than the brief description that I just gave you, but that's the long and short of the ingredients that go into PVC. But from there, you can add plasticizers to that PVC to give it varying degrees of flexibility. So PVC can be rather stiff and hard, or it can be rather flexible. And in the roofing industry, it's going to be rather flexible. So PVC has been around since 1838 and first started being plasticized in 1926. So it's used in a wide variety of products. It's used in the medical industry, it's used for saran wrap, it's used for shower curtains, it's used for grill covers, it's used for many different types of applications. So going back to the slide with the two red cars, there's quite a wide variety of qualities and formulations for PVC. But for roofing, it needs to be a rather flexible product that maintains its flexibility over time because it will be exposed to UV for many years. So PVC was first used in the roofing industry in the United States in the 1970s. And PVC, as part of all of single-ply roofing, has been growing in demand continuously for the past 15 years. Back in 2001, single-ply only accounted for 58% of the total low-slope roofing market. And as of the end of 2015, single-ply roofing, meaning EPDM, PVC, and TPO, accounted for 83% of the total low-slope roofing market. So single-ply in general has been on the rise, and there's many, many reasons for that. One of them being the ease of installation versus some of the other product categories that are out there. Certainly cost is always a consideration. There's been a growing demand for white reflective roofing over the past 10, 15 years as well. PVC is also involved in a lot of different product segments within the PVC category. And so you have standard polyester reinforced PVCs, which is the largest percentage of PVC roofing applications. You have the fiberglass reinforced in the purple, strictly used for fully adhered applications. As mentioned earlier, you can have fleece back. That's a polyester fleece that is on the bottom side of the PVC membrane. There's also a formulation called KEE, which we'll get into a little bit later, but it's an enhanced plasticizer for PVC. PVC can also be made into various colors. But typically PVC is sold in the color white, but there's gray, there's tan, and there's specialty colors. And then there's also a metal profile product available that it's actually a rib that's used in conjunction with the flat membrane to replicate the look of a standing seam metal roof. So quick history recap, PVC has been performing in roofing for over 50 years, and it's the only thermoplastic single-ply membrane that doesn't come 100% from fossil fuels. And then we talked about the various fragmented sectors of the PVC markets. Some of the key benefits of PVC. Biggest benefit is that it does have a long-lasting track record, being used in the U.S. for over 50 years. Of all of the single-ply systems, PVC is the most chemical resistant. So in terms of jet fuels, diesel fuels, also animal fats, vegetable oils. The other nice thing about PVC is it is very, very flexible in both cold and warm temperatures. And then of all of the single-ply systems, it is the most fire resistant, and we'll talk about that. Being a thermoplastic product, the seams are heat welded, so you're not utilizing tape or adhesive for adjoining side laps and end laps of this sheet. Talking about fire resistance, PVC has the best testing for spread of flame and burning brand. What spread of flame is measuring the distance that a flame will spread in a certain period of time. And one of the reasons this one is important, if you have a fire within a structure, you don't want flames coming out of a window and coming up over top of the roof system and spreading. And then burning brand is a resistance to embers that might land on the roof from a structure that is on fire, perhaps next door. One of the things about PVC is that for burning brand, that it is self-extinguishing, so it doesn't contribute to that source of the fire. From a workability standpoint, the heat welded seams with PVC actually have a bleed out, so you can actually see that you have a proper weld if you're looking at some bleed out in that weld. It's a key difference between a TPO and a PVC product. Very sustainable product as it does have a long lifetime. You can recycle PVC membranes that have been in place. In the manufacturing process, there is not a lot of energy used to produce the product. And so with the recycled ability of the PVC, you have a lot of attributes environmentally for the product. Because it is white in color, it can contribute in certain market areas to some potential energy savings due to the reflectivity. But each market is different, and you have to check out the specifics of the location that you are in. So that weathering package is contained in the top ply of the PVC membrane. So that top ply PVC will be more expensive than the bottom ply. And that top ply has to provide that heat resistance, UV resistance, and abrasion resistance for foot traffic. So the common types of reinforcements, the most popular is a polyester reinforced sheet. As mentioned earlier, there's a fiberglass reinforced product for fully adhered applications only. You have KEE, ketone ethylene ester is what that stands for, and KEE HP, high performance polyester reinforced, and then you have fleeceback reinforced with typically fiberglass, but it can be reinforced with polyester as well in certain instances. The main ASTM standard for PVC is ASTM D4434, and it would call for a physical properties content and a polymer content. So there's two aspects to that ASTM. So you have to have a 50% or greater PVC polymer, and there's a minimum thickness criteria and minimum thickness over scrim. So you can see the minimum thickness is 36 mil. Minimum thickness over scrim is 0.016. Within that ASTM, there's different types. So you have type 2, which is the fiberglass, type 3 and type 4, polyester reinforced. They'll have different minimum thicknesses and differences for higher tearing and breaking strength between type 3 and type 4. For example, type 4 would have a higher breaking strength, 38% greater than a type 3 material. It would have a 66% greater elongation and 100% greater tearing strength just in type 4 to type 3. So ASTM D4434 type 4 would provide you with the best characteristics in those categories. When we look at the difference between a polyester and a fiberglass reinforcement, if it is mechanically attached, it has to be polyester. So we're really looking at a fully adhered application. So in that fully adhered application, that polyester would provide a 400% increase over the fiberglass in terms of tearing strength, fiberglass being kind of brittle. Also, it would have a huge breaking strength increase of 467%, and then a much better puncture resistance than the fiberglass. The reason that you might ask yourself, the reason then why is fiberglass ever used, is because in a fully adhered application it does have the best linear dimensional change. And so that is the one benefit of the fiberglass, but it's really kind of a minimal difference between the fiberglass and the polyester. So there are manufacturers that allow polyester or fiberglass in a fully adhered system. There are others that simply have a fiberglass for fully adhered. One of the things in that ASTM is the thickness over scrim, so that's a very important component of the manufacturing process. It's also an area where you can distinctly change the characteristics between, going back to that analogy of the two red cars. You want a proper amount of thickness over scrim. You don't want all of your thickness over scrim to, you don't want your total thickness to come from the bottom ply. You want it to come equally top over bottom. So it should be centered. And you can see, looking at a microscope, there is a key difference in the top ply versus the bottom ply, and there's a lot more cost in the top ply. So you want an adequate amount of top ply over the scrim. Sometimes you'll see in a microscope excessive bottom ply, and that reduces the weathering performance of that same 60 mil product. Other products have thickness over scrim, but they also have a couple different layers on top of that scrim. Or a type of coating, a coating on the top that resistance to dirt, and that is a small percentage of the total thickness. So there's various ways that PVC is manufactured. A benefits recap: of all the single ply systems, PVC has the best fire performance testing. It is a sustainable product in that it can be recycled, and it is a low energy product to produce. PVC uses heat welded seams, no tapes or adhesives, and the weathering package will be in the top ply of thickness over the scrim. So beware of membranes with a thinner top ply. And there will be published thickness over scrim in most manufacturers' product data sheets. KEE, ketone ethylene ester, is a plasticizer enhancement, and it provides higher performance characteristics. It is a more expensive plasticizer enhancement, remembering that plasticizer provides the PVC with long-term flexibility. So KEE was developed back in 1973. Typical plasticizers are liquid plasticizers, and this ketone ethylene ester, which was developed by DuPont, is a solid high molecular weight polymer. So it's a much heavier molecular weight product that will not leach out of the product over time. So the sheet will remain flexible for a longer period of time, and it also enhances the chemical and oil resistance of the product as a result of that. Typical formulations, you have liquid plasticizers, and then the KEE is a solid plasticizer additive. Key advantage to maintaining that plasticizer is that it will have longer term weather resistance, which would give it better UV resistance and provide it with longer term flexibility in both cold and warm temperatures. But the real difference is in performance versus diesel fuels, jet fuels, and animal fats and vegetable oils. PVC being a thermoplastic product, there are a lot of prefabricated flashing accessories that are available. There are square tube wraps, split pipe seals, inside and outside corners, and there are prefabricated curb wraps. One of the key differences between KEE products and standard PVC products are that KEE products will smoke less when welded. PVC products do tend to give off some smoke. It's an irritant. You can smell it. It is not classified as dangerous to the installer. And KEE products tend to smoke less than standard PVC products. The other key attribute with the KEE is with that longer term, heavier plasticizer, it tends to resist the accumulation of dirt over time. So choosing the right product and system. There are mechanically attached systems where you have mechanically attached the insulation with fasteners and plates and then fasten in the seam. There's also the fully adhered option, and there are a number of different types of adhesives. There are low VOC adhesives, and there are water-based adhesives for standard PVC as well as KEE products. You want to keep in mind as we head into the winter months, there are temperature restrictions on certain water-based bonding adhesives and low VOC products. There's also an induction welded system where there is a coating of PVC on the top of the insulation plate. And so there are patterns for attachment of the insulation. And then there's a machine that you'll induction weld the bottom of the membrane to the top of the plate. After you induction weld, you'll place a weighted magnet over that plate till it cools. And it provides pretty good attachment in a lot of different touch points than a standard mechanically attached system. So an induction welded system is kind of a hybrid between a mechanically attached and a fully adhered system. PVC is also available with a fleece back. And the fleece back is a polyester fleece that is on the bottom side of the membrane. The key attributes of fleece back membranes are that it has enhanced puncture, hail, and uplift resistance. And the results are pretty dramatic in terms of the resistance to hail and puncture. The other thing is, if you're doing a re-roofing application, it's a very quiet installation. You can actually utilize the same adhesive for insulation attachment as you would use for membrane attachment. So there's minimal disruption for interior occupants if using this type of product in a recover or re-roofing application. That polyester fleece dramatically increases the puncture resistance of that membrane, and it outperforms in ASTM D5635. PVC outperforms a modified bitumen in terms of puncture resistance. So take a look at the fleece back installation. The adhesive for a fleece back installation can come in a number of different ways. It can come in a dual cartridge adhesive, and in this case it's being dispensed in a ribbon form. And there's different patterns of ribbons that can be used for fleece back application. And keep in mind, for this type of adhesive, there are also, as we head into these colder temperatures, there are some restrictions and guidelines that need to be followed for proper storage of materials and installation of adhesives in colder weather. Once that adhesive is dispensed, it will be in a liquid form, and then in a minute or two it will rise to a foam, and we do what's called a string test to that rising foam, and then we'll set the membrane into that adhesive. Upon completion of that, we want to roll that in with a 150-pound weighted roller. Because depending on the bead spacing of that adhesive, you don't want that ribbon telegraphing visually through that membrane. So one of the things we want to do is definitely check that string time, let that adhesive rise, but not wait too long, so there is a window of opportunity there. One of the things you can do to minimize that is to have a little tighter bead spacing, and then definitely want to hit it with the 150-pound weighted roller once that membrane is placed into that adhesive. So there's different types of equipment to dispense the adhesive. It can be in a dual cartridge. There's also dual tanks. There's a system called bag in a box with an A and a B, and in this picture here there's a full spray. There's a a product called a heated predator, which can actually full spray the adhesive. You don't want to spray the adhesive in areas where it's not intended to be, so you do have to take some precautions. This is a low VOC product. Of course, they're wearing protective equipment, but it is a low VOC. And really important is to get good adhesion of that membrane into that adhesive. So the 150-pound weighted roller is very, very important upon the completion of installing that fleece back membrane. Another interesting application is the PVC rib profile. And so you have PVC ribs, and you can replicate the look of a standing seam metal roof. And where this comes into play is maybe an area where it's challenging. It could be a dome, it could be any number of circumstances that lead you to an actual standing seam roof. But from a cost perspective, the PVC rib is a pretty good value versus the standing seam metal. You won't want to use the fleece back membrane that would hide the fasteners and plates from telegraphing through the membrane. So heat weld that rib to the membrane. And that can come in a variety of different colors. Little products recap. ASTM D4434-12 Type 4 has the strongest testing for breaking strength, tear strength, and elongation. There's several attachment methods for PVC. You have mechanically attached systems. You have bonding adhesive and fully adhered systems. You have fleece back available with a urethane adhesive. And then you have an induction welded system. As far as KEE, ketone ethylene ester, that is a plasticizer additive, a high molecular weight plasticizer that provides greater flexibility in cold temperatures and warm temperatures, and the most chemical resistance in terms of petrochemicals and animal fats and vegetable oils. And then lastly, it does the best job of resisting dirt accumulation on a clean white roof. As far as fleece back PVC membranes, that fleece back is a polyester fleece on the bottom side of the membrane, and it provides enhanced puncture, hail, and wind uplift. Right now, I'll take any questions that you have, because this will conclude the AIA portion of the presentation. One of the questions was, can you use KEE flashing materials with standard PVC? And the answer to that is yes, you can use KEE products with standard PVC products. All right, if there are no further questions, you will be receiving a 1-hour AIA learning unit. All you need to do is, if you've registered, you'll receive it from Ted.
There's one question.
There's one more question.
No, you can see it. It says, how describe how fleece back helps the uplift pressures, or helps the uplift on a membrane.
Oh, one of the questions was, in essence, why is fleece back enhanced for uplift pressures? Because that fleece, that polyester fleece, is bonded to the underside of that PVC membrane, and so it is that fleece embeds into that adhesive, and as a result of the embedded fleece into the adhesive, and that the fleece is bonded to the underside of the membrane, from an uplift testing performance characteristics, it provides the highest uplift testing of all the different single-ply systems. So it would test out better than just a standard bonding adhesive or water-based bonding adhesive with a bareback PVC sheet. So it's really the bond of that fleece to the membrane and that urethane adhesive and the strength of that urethane adhesive that tests out better than a standard bonding adhesive or water-based bonding adhesive.
Aren't all accessories KEE?
Another question was, are all accessories KEE? It depends on the manufacturer of PVC. So some manufacturers do not offer KEE products. Some manufacturers simply offer standard PVC. Some manufacturers offer only KEE products, and then some manufacturers offer both. So in some cases, a manufacturer may offer KEE accessories with standard PVC, but that's not the case with all manufacturers. So keeping it generic, I'll say that yes, in some cases it is, and in some cases it isn't. It depends on the manufacturer.
TPO versus PVC. Building owners want to know why they choose one versus the other.
Question came up, TPO versus PVC, why would a building owner prefer one over the other? Great question. As we talked about, PVC tests out better in resistance to animal fats, vegetable oils, petrochemicals, diesels, etc. It also has the best fire characteristics. But if you had to rank single-ply membranes in terms of cost, the PVC will cost more per square foot than a standard TPO, and a KEE product will be an enhancement in cost to a standard PVC. So it really depends on the budget of the owner, the length of time that they want to be in the structure, and how much they want to spend. I would say that TPOs generally do fairly well with animal fats and vegetable oils, but really when you get into the petrochemicals and diesels, etc., is where the PVC really, and the KEE in particular, really does much, much better. Another question. Aren't all the PVC flashings and accessories now KEE as standard? This is a continuation of the previous question. Since we've concluded the AIA portion, I'll answer the question in terms of Carlisle's perspective. For Carlisle, all of the prefabricated flashing products are KEE that go with a Carlisle standard PVC system. That is not the case with other companies that only offer standard PVC products.
Okay, you just answered three of them, the same thing as Carlisle, all KEE.
And I think that answers a couple of different questions here.
There's another one.
Ribbon attachment of fleece back. Can it be as good as full coverage? Good question. So it depends on the ribbon spacing. So a 4-inch ribbon spacing is actually considered full spray. And the reason for that is because the tightness of that 4-inch, when that membrane is placed into that 4-inch ribbon, it will spread out and actually be full coverage as one ribbon meets the others when you hit it with a 150-pound weighted roller. Where you do have to worry about that telegraphing of the ribbons is when you get wider bead spacing. So when you're looking at 12-inch and 6-inch bead spacing, you have to take more care to make sure that the 150-pound weighted roller is rolling out those ribbons. In those cases where you have the 12 and the 6, there is that potential for some telegraphing of that adhesive ribbon. It's not going to affect the functionality of that system, but you might need to know that aesthetically, if you're going to be looking down at that roof, and aesthetics are extremely important, that you might want to consider a tighter bead spacing.
Next, list of acceptable substrates.
List of acceptable substrates, and I'm guessing that that is for a fully adhered or fleece back. And good question. So for a substrate for fully adhered or fleece back, you can go with standard polyiso. You can go with a cover board of a high density coated glass polyiso. You can use a cover board, a glass mat gypsum. It can also be attached to OSB or plywood. So there are a number of different substrates that you can fully adhere to.
Can you get custom colors, and where can you find a color chart of the available colors?
And you get custom colors. Yes, you can get custom colors, and a custom color chart can be emailed to you. If you email either Ted at Premier BLDG Products or Greg at premierbldgproducts.com, we'll make sure you get a color chart. There is an upcharge and some minimum square feet criteria for custom colors. The standard color offering, at least from Carlisle, is white, gray, and tan. The other question that comes up is logos, and so there would be the same criteria for custom colors on logos for a rooftop.
Next question, how do you ensure that PVC ribs that are installed after the fact get installed in straight lines?
Question was, how do you ensure that ribs are installed in straight lines? One of the things would be to do a pattern. There's a number of different patterns that are available for the rib placement, and then practice would lead to chalk lines to ensure that the ribs are put in place in a straight way. There's also interlocking ends to those ribs, so they can stay in a straight line themselves, and they're very, very rigid, actually. Flexible on either side so you can weld, but they're pretty rigid. Next question?
That's it.
All right, a lot of good questions. Okay, well, thank you for your time and attention. You will be receiving a SurveyMonkey survey of this presentation. Encourage you to answer the SurveyMonkey. We'll have more of these types of webinars in the future, and appreciate your time and attention this morning. Have a great day.
Yeah, that's good though.